All right, this is the polar review for BC. So first thing we need to remember is that x is equal to r cosine theta, y is equal to r sine theta. The area is given by this integral. And remember, what we're doing is we're cutting theta wedges. So if we have a circle that looks like this, or whatever it looks like this, you're going to cut d theta, and you're going to go from theta as you're going from theta equals 0, or wherever you need to, up into 2 pi. Okay, so here's the area of a circle. But we're going to find just a fraction of that. So that's going to be theta, the amount of degrees that you're concerned with, over 2 pi. And you can see there's the pi's would cancel. This is the area of the sector that we're working on. But remember, the radius and theta are constantly changing, so we're cutting little theta wedges, and it ends up being this area. So that's where the 1/2 comes from, is the fact that you're doing a proportion of a circle. So this angle, like maybe I'm finding from 0 to pi over 3 of 2 pi. So it's the fraction of the circle. Remember, the distance from the origin is r, and slope of the tangent line is dy d theta over dx d theta. The other ones that we had to memorize, of course, was r squared is equal to x squared plus y squared, which is just the Pythagorean theorem using those two. And then tangent of theta reference, which is the angle in the first quadrant, is the same thing as y over x. So there's a couple things we need to learn how to do in this chapter. Of course, convert back and forth between polar and Cartesian. Differentiating, taking derivatives of them, describing the particle motion, the area between a polar curve, and area between two polar curves. We should also be able to find tangent lines, maxes, mins, determine if something's moving to the right or left or towards the origin. So our first one looks like this. We have a graph above, and here is the equation of the graph. And it's between 0 to pi. And you're going to let S be the region bounded by that in the x-axis. Okay, so if you want to figure out what this is, because it's on the x-axis, you're going to imagine that x is equal to 0 or pi. If you're on the x-axis, it's got to be 0 or pi for theta. If you're on the y-axis, it's either got to be pi over 2 or pi. So I'm guessing that this is where we are at theta equals 0, and this is where we are at theta equals pi. And how I'm really going to stop and determine that is I'm going to plug it in to my equation. So here, r of 0, not theta, is equal to 0 to the 1.5 plus cosine of 0. Remember, cosine of 0 is 1, so r of 0 when theta is equal to 0 is equal to 1. And I could also find out that at theta equals pi, it's going to end up over there. So if I want the area of this, remember we're cutting our theta wedges. So our area is going to be 1/2 the integral from 0 to pi of r squared and they will not ask you to integrate this by hand. You can put it in your calculator, and you're going to get this as approximately equal to, not that I copied it wrong, this. Now remember, whenever you put these in your calculators, first of all, you're going to remember that you have the squared right here, very easy to forget, and the 1/2. Sometimes we don't see the 1/2 because we've used symmetry, but it is in the original formula. You need to make sure your calculator is in radian mode. You do not need to switch your calculator to polar mode in order to integrate. Just keep it in Cartesian, but make sure you're in radians. So this time it wants the area between the inner loop of this polar graph. So here r is equal to 1 plus 2 sine theta. The first thing I'm going to determine is when I pass through the origin. We pass through the origin when r is equal to 0. So we know that sine theta has got to be equal to negative 1/2. So sine is negative in quadrant 3 and 4. And it's 1/2 when it has to do with pi over 6, but we're in quadrant 3 or 4, so 7 pi over 6 and 11 pi over 6. So where are we at theta equals 0? So here's our formula. So if we plug in theta equals 0, that's just going to be 1. So this is where we start at theta equals 0. We follow counterclockwise. We keep going counterclockwise. Here's pi halves. Here's where we enter. This is pi. When we enter, we know that it's 7 pi over 6. When we get over here, that'll be 3 pi over 2. Remember, whenever you're in the inner loop, it's negative values of r. So here's 3 pi over 2. It really maps backwards. And then you go around, that's 11 pi over 6. So you notice we've got a couple choices here. We got 7 pi over 6 and 11 pi over 6. So that looks like it's going to be the one we want. But let's go ahead and double check why the other ones don't work. So this one's negative pi over 6, which is the same thing as 11 pi over 6. So that's going backwards. If we're going 0 to pi over 6, it's starting our theta wedges here and going and keeping all the theta wedges until you enter. And this one is going through the entire loop all the way through. So it's going to actually go over the inner loop twice. So C. 4. Let R be this curve defined by this. Find the values of r theta at the y-coordinate of the polar graph at 4 pi over 3. Explain what these values represent in terms of the graph r. Okay, so if that's r, then we know y is equal to r sine theta. r is this value. Now this is a calculator problem, so you can go ahead and take the derivative in your calculator. And after we do that, so if I take the derivative, dy d theta, hold on, did it want dy d theta? No, it just wanted the y-coordinate, so I don't need to take the derivative. So all I'm going to do is plug in theta equals 4 pi over 3. I'm going to do that directly in my calculator, and we get the value negative 15.195. So this is the y position when theta is equal to 4 pi over 3. So r is on this curve, and we want to know when r is decreasing. So that will be when dr d theta is less than 0. So just like in Calc 1, the first thing we're going to do is take the derivative. So r, which is equal to theta minus 2 cosine theta. So r is equal to dr d theta. The derivative is equal to 1 plus 2 sine theta. And we need to figure out when this is equal to 0. So sine theta is equal to 0 is equal to negative 1/2 at theta equals 7 pi over 6 and 11 pi over 6. So that's the only time we're going to pass through 0. And if we're not passing through 0, that means we're either going to be positive or negative. So between 0, you'll be either totally increasing or totally decreasing. So if I choose like theta equals pi halves, and I test it into my function, we're going to have pi halves minus 2 cosine of pi halves. Cosine of pi halves is 0, so this goes away. So this is positive, which means it's going to be increasing. So on the next one, it's going to be decreasing, and the last one's going to be increasing. So it's decreasing between 7 pi over 6 and 11 pi over 6 only, which is B. You could have also taken the second derivative to show that it was in fact a where the max and min were, and then you would know between them whether it's increasing or decreasing. Let theta be a particle. We're going to have a particle still on this graph, so now a different graph. Find the maximum distance from the origin. Okay, so the maximum distance are going to be from the origin is going to be when we maximize this. So to maximize, we're going to have to take a derivative. So first thing, we're going to take our derivative of this. So r prime would then be 2 plus chain rule, so 12 sine 3 theta is equal to 0. So then sine 3 theta is equal to negative 1/6. Now this is a calculator problem, so you're going to go ahead and use your calculator to find out exactly what theta needs to be. So it's probably easiest to go back to this one to figure out what it needs to be. So our theta values that work for this is either 1.10301, and the other place it crosses is 2.03857. Again, do not put this in Cartesian. Just don't put it in polar, leave it in Cartesian. You're just going to put this in here, and you're going to look where it crosses the y-axis, the x-axis. Okay, so we got to figure out which one's a maximum, so we can either do the second derivative or make our table. So here we are at 0, 1.0103, 2.0385, and of course 2 pi. So our values are -4, and not 2 pi, I meant pi. And the next one would be plugging it in, 6.15, 0.133, and of course at pi it is 10.2813. So this one's your maximum, so its maximum distance from the origin is 10.283 units, and it happens at theta equals pi. So we want to find out where this r value, find the theta value for when the x-coordinate is -3. So the first thing we're talking about is the x-coordinate. Remember, the relationship is x is equal to r cosine theta. So this would be 3/2 theta plus 2 cosine theta squared over 2 times cosine theta. And we want to know when x value is equal to -3. So you're going to put this in your graphing calculator. Put this under y1, put this under y2, find the first intersection point, and the first intersection point will be theta equals 2.585989. All right, so you have the graph of the polar curve above, and it wants to know which of the following statements are true for r at this value of theta. So they want to know if r is getting closer to the origin. Well, if it's getting closer to the origin, then we know dr d theta has to be less than 0. If it's getting closer to the x-axis, then we know that dy d theta has got to be less than 0 because we're over here at 5 pi over 6. And if we're getting closer to the y-axis, then we know dx d theta has got to be less than 0. So we have to find all those. So the first thing we do, it's a calculator problem. So you're just going to go for dr d theta, do the derivative straight in your calculator. At theta equals 5 pi over 6, we get that this derivative is equal to 1/2. So we know that dr d theta is not getting closer to the origin, it's getting bigger to the origin. Sorry, I wrote that wrong. Okay, so the next one we're going to talk about is the x-axis. If we're going towards the x-axis, we're going to be looking at dy d theta. So remember what y is. Y is equal to r sine theta. So put that in your calculator. And when we take that derivative at 5 pi over 6, we get the value of negative 0.22707, and that means that it is getting closer to the x-axis, so we know this is true. And then we can do the same thing with dx d theta. Remember that x is equal to r cosine theta, so dx d theta at that theta value is equal to positive 0.7 0.0845. So this is positive, so we know we're moving, increasing this way, so we're moving away from the y-axis. So that's not true. So the only one that is true is 2. It should say 2. They updated it and I didn't check it. B, find the slope of the line tangent to that at pi over 6. Okay, so most of the time when they ask you to find the tangent, it's almost always at pi halves, pi something very easy. Pi over 6 is technically a little bit harder than they normally ask, but if we're talking about the slope of the tangent line, remember that you're going to find, you want dy over dx, but that's the same thing as dy d theta over dx d theta. So you're first going to find dy d theta and dx d theta. So for this equation, y is equal to 1 plus cosine theta sine theta. So y prime, derivative of the first one would be minus sine theta, copy down the second piece. Derivative of the second piece, copy down the first piece. And this is all at pi over 6. So let's see, sine of pi over 6 is 1/2, so you're going to have negative 1/4. Cosine of pi over 6 is root 3 over 2. 1 plus root 3 over 2. So that's the y prime. Now they do the same thing with x. X is equal to r cosine theta. So x prime is equal to minus sine theta cosine theta. Derivative of the first, copy down the second, plus derivative of the second, copy down the first. And again, we're going to be evaluating this at pi over 6. And let's see, at pi over 6, you're going to have negative 1/2 times root 3 over 2 minus the sine of pi over 6 is 1/2, and then 1 plus root 3 over 2. And as we go through and simplify that, I believe we get negative 1. So now we have this new shape, and it wants us to find the area of the common region. They did not give us the intersection point, so we first need to find the intersection point. These two intersect at theta equals 0.78539. And what you're going to do is put both of these equations into your calculator. Do not change it to polar. Leave it in Cartesian. See the first place where they intersect each other? The x value of that will be equal to the theta value. So find the area of the shaded region. So remember, when we do polar area, we're cutting theta wedges. So remember, the area formula is 1/2 the integral of r squared d theta. So we're cutting our theta wedges. So if I imagine starting at theta equals 0, remember this is where theta is equal to 0. At first, I'm cutting to the cardioid shape, which is R1. Oh, that's R2, sorry. R2. And then we're going to, at this intersection point, switch to the peanut-looking shape, which is R1. So our integral is going to be 1/2 the integral from 0 to this value a of R2 squared d theta. And then same thing, we're going to have 1/2. We're going to start at a this time, and we're going to integrate all the way to pi halves of R1 squared. And this works out to be 3.44341. And again, it's a calculator problem. Put it directly in your calculator to integrate. Make sure you're in radian mode. Find where r prime of theta is when theta is equal to 4 pi over 11. What does this indicate about the graph of R1? Okay, so if we're asked to find r prime, that's going to be dr d theta of R1 at 4 pi over 3. We can do that correctly in our calculator, and we're going to get the value negative 1.51149, We know that drd theta is less than 0, which means the graph is decreasing, which means it's moving closer to the origin. So r is decreasing. Graph moves towards the origin. All right, the next part asks us to find if the y-coordinate of R2 is a maximum. So the first thing we're going to do is find the y-coordinate. Y-coordinate would be R2, which is root 2 sine theta plus 8 theta over pi times sine theta. And we want to know if that is a maximum. So we're going to have to take the derivative of this and set it equal to 0. So the derivative y prime would be the derivative of the first piece, so square root of 2 cosine theta plus 8 over pi, copy down the second, plus the derivative of the second, copy down the first. And we're going to evaluate this at, no, we want to know when this is equal to 0 because we're looking for a max or min. So we're going to take that and put it in our calculator, and it's equal to 0 when theta is equal to 1.8976. We're on a closed interval from 0 to pi, so you're going to check your endpoints. So when theta is equal to 0 and pi, or this 1.8976, you're going to put it right back in here, and we're going to figure out which y value is the biggest. So here we get 0, here we get 0, and the middle one is 5.898442. So this is a maximum y value at theta equals 1.89. Let y of 2 and x of 2 and x of t, y of t represent the position of the particle along R1 where t is equal to theta. Find the position of the particle at time equals 2. Okay, so first thing we're looking at R1. R1 is equal to 3 plus 2 cosine theta. So let's write that down. R1 is equal to 3 plus 2 cosine 2 theta. And we want to know the position at time equals 2. Well, that's going to be the same thing at position when theta is equal to 2. So remember that x is equal to r1 cosine theta. And we're going to evaluate this at 2. Then we're going to do the same thing with y. Y is equal to r1 sine theta. So y at 2, just plugging that in, you're going to get the x value is negative 0.97642, and then the y value is 2.13353. And again, just make sure you're in radian mode. Find the area of the inner loop of this one, which I believe we already did one very, very similar to this. So first we're going to figure out where we enter our inner loop. So, and then exit our inner loop. That is when r is going to be 0. So sine theta has got to be equal to negative 1/2. So we know that our sine value, its reference angle is pi over 6, but it's got to be in quadrant 3 or 4, so 11 pi over 6. So at theta equals 0, remember we find that by plugging 0 in for theta. You're going to get 1 plus 2 sine 0. So r is going to start here at 1. It's going to go counterclockwise. Here we are at pi halves. Here we are at pi. We're entering at 7 pi over 6. This would be 3 pi over 2, because remember, if you're on this axis, it has to be either pi over 2 or 3 pi over 2. If we're on the x-axis, it's got to be either 0 or pi. So since this is in the inner loop, we know that the r is negative, so it had to come from 3 pi over 2. If I wanted to stay inside the inner loop, it would be from 7 pi over 6 to 11 pi over 6. I do not see that anywhere. If I want to do half of the inner loop, that would be from 7 pi over 6 to 3 pi over 2, then we'd multiply by 2 to get the symmetry. And that is this one right here, D. The graphs of the polar curves, those two polar curves are shown to the right. At which values of theta do these intersect? Again, it's a calculator problem. You're going to take one of them, set it equal to the other, and you're going to find the theta values where they cross. Given the polar curve, which of the following could be theta if x is equal to 2? So remember, x is equal to r cosine theta. So x is equal to 2, which is 8 cosine theta times cosine theta, so cosine squared, which tells us that cosine squared theta is equal to 1/4, which tells us cosine theta is equal to plus or minus 1/2. So cosine is 1/2 at pi over 3. So it would be pi over 3 and all of his friends.